Hey there, and welcome to this explainer. Let's dive right in, because we're looking at something you probably see every single day, but never really think about: the color of your eyes. You might think your eye color is just a matter of aesthetics, right? Maybe just a nice trait you inherited from your parents. But honestly, it's so much more than that. Your eyes are literally a biological roadmap. They hold this incredible, ancient story of exactly how your ancestors adapted to completely different environments, and, ultimately, conquered the planet. Now, just to put things into perspective, the sheer scale of human genetics at play here is absolutely fascinating. Take a look at the baseline of our species. Over 70% of all humanity shares just one highly protective eye color, and that's brown. But what about that remaining 30%? Well, that slice represents a wild, incredible story of genetic mutations, ancient migrations, and some pretty extreme evolutionary adaptations that played out over thousands and thousands of years. So, how exactly did we get this massive spectrum of colors? Well, here is our agenda for this explainer. We're going to start with the ultimate biological shield, then explore the great genetic mutation that changed everything. After that, we'll check out the rarest color variations, dive into nature's ultimate chameleons, and finally, we'll wrap up by looking at some truly extreme genetic anomalies. Let's get into it.
Section 1. The Ultimate Biological Shield. Let's start right at the beginning, with the absolute baseline of human survival.
We are talking about the ultimate protector, brown eyes. That deep, rich color you see in the vast majority of the population, that comes from a powerful pigment called melanin. And research from the University of Copenhagen confirms that melanin is essentially your built-in natural sunscreen. Think about early humans migrating across the harsh, sun-scorched African savanna. Dealing with that brutal, relentless UV radiation meant having brown eyes wasn't just cosmetic. No way. It was absolutely vital for survival. This pigment is so incredibly powerful that it absorbs up to 90% of the light entering the eye, stopping harmful ultraviolet radiation right in its tracks before it can cause any DNA damage to your eye cells. But here's the really cool part. Brown eyes don't just protect you, they actively perform better in bright light. Because they absorb all that incoming light rather than scattering it around, brown eyes significantly reduce glare. Yeah, people with brown eyes actually experience way less glare sensitivity, which means they maintain much clearer vision in intense, blinding daylight. It's a massive evolutionary advantage, and it perfectly explains why brown eyes absolutely dominate in populations living closer to the equator. I mean, it is perfectly optimized biological engineering for high sun environments.
Moving on to Section 2, the Great Genetic Mutation. Let's see how human migration completely rewrote our genetics.
So, as humans migrated away from that equatorial baseline, things started to change. But before we get into how lighter eyes spread across the globe, I've got a quick myth-busting question for you. When you look closely at someone's blue eyes, are you actually seeing the color blue?
The answer is a hard no. Seriously, there is absolutely no blue pigment in your iris whatsoever. None. What you're actually looking at is a total masterpiece of structural physics. Blue eyes contain almost no melanin at all. So when light enters the eye, the longer wavelengths pass right through to the back. But the shorter blue wavelengths? They hit the cellular structure and scatter right back out to whoever is looking at you. It is the exact same light scattering effect that makes the sky look blue on a clear day. Your blue eyes are, quite literally, a trick of the light. So where did this biological optical illusion even come from? Well, according to human genetics research, get this. Every single blue-eyed person alive today descends from just one single ancestor. Yeah, you heard that right. Sometime between 6,000 and 10,000 years ago, a random mutation occurred in the HERK2 gene that literally just switched off the body's ability to produce brown pigment in the eyes. This happened right around the Neolithic expansion, exactly when early farming communities were spreading out from the Black Sea region. And here's the mystery that still kind of baffles researchers. This mutation spread incredibly fast. I mean, it went from 0 to a 95% frequency in parts of northern Europe today. It just spread like wildfire.
And this brilliantly illustrates a massive evolutionary trade-off. While brown eyes were giving maximum UV protection down at the equator, researchers believe that having blue eyes allowed more photons to actually reach the retina. And why does that matter? Well, it potentially enhanced vision in the incredibly dim, dark conditions of those long, brutal northern European winters. Oh, and here's a mind-blowing fact from ancient DNA analysis. Early Europeans actually had blue eyes paired with dark African-like skin. Seriously, this proves once and for all that light eyes actually evolved way before pale skin did, totally destroying the old myth that blue eyes were just some accidental byproduct of human skin getting lighter.
All right, Section 3, the rarest color variations. We're stepping into the territory of delicate biological balancing acts. Let's talk about gray eyes first. They are exceptionally rare. We're talking less than 3% of the entire global population. They actually contain even less melanin than blue eyes do. And because they have so little pigment, they scatter light so broadly across multiple wavelengths that they end up looking steel-like or silver. Functionally speaking, researchers think this was an extreme adaptation for the constant, overcast, cloudy climates of Northern Europe, giving those populations a really neutral, stable visual field. But culturally, well, because the color is so flat and doesn't shift very much, gray eyes are notoriously harder to read emotionally. They often give off this vibe of cool detachment or quiet wisdom.
Now, what if I told you that to get green eyes, it takes a precise, delicate cocktail of at least 16 different genes perfectly balancing each other out? I mean, talk about high-maintenance genetics. If you have just a little too much melanin, boom, they turn brown, a little too little, and they go right back to blue. Because of this tightrope walk, just 2% of the world's population sits in this exact genetic sweet spot. Green eyes happen when you take a moderate amount of melanin and mix it with a highly specific yellow pigment called lipochrome. When light hits that specific combination, you get that distinct green hue. But it's chemically unstable. This means green eyes are highly sensitive to environmental light, constantly shifting from mossy green to golden depending on the room you're in, or honestly, even the color of the shirt you're wearing. This dynamic, almost magical shifting quality gave early humans great evolutionary flexibility in highly variable environments, like dense, temperate forests. Though, historically speaking, that same color-shifting magic definitely led to folklore associating green eyes with mystery, the supernatural, and even witchcraft in medieval Europe.
Moving to Section 4, nature's ultimate chameleons. Let's dive into the absolute rarest categories of eye color out there. Looking at the rest of the spectrum, we've got some true biological marvels. Let's look at hazel first. Hazel eyes mix an intermediate amount of melanin with traces of that lipochrome we just talked about, making them true chameleons. They physically change appearance based on the lighting around them, which provided incredible evolutionary versatility for folks living in mixed climates with changing seasons. Then you've got amber eyes. These feature high lipochrome but super low melanin, creating this solid, stable copper or golden color that really doesn't shift at all. It's incredibly intense, very similar to what you see in predatory animals like wolves or eagles. Because of this, researchers actually think amber evolved more as a strong visual signal for mate preference rather than a specific adaptation to light. And finally, true black eyes. While technically just an extreme, super dense concentration of dark brown melanin, they are so heavily saturated that they just appear flat black. This offers the absolute maximum UV and glare absorption possible for populations living right on the equator, while simultaneously masking any emotional pupil dilation. It projects pure strength and total inscrutability. And finally, Section 5, extreme anomalies in genetics. Let's see what happens when the genetic lottery just breaks all the rules entirely. We are talking about heterochromia. This is an extreme genetic anomaly that affects less than 1% of the population, where someone literally has two entirely differently colored irises, or stark, visible color splits within a single eye. Usually, during early fetal development, melanin distributes itself perfectly evenly across both eyes. But in heterochromia, that symmetry gets completely disrupted by minor genetic mutations or something called mosaicism, which is basically when a person has two different sets of DNA operating in their cells at the same time. Because human beings subconsciously expect and specifically look for perfect visual symmetry when we look at a human face, breaking that symmetry is really startling. It catches our attention immediately. And that's exactly why, historically, heterochromia deeply fascinated ancient cultures. They often viewed it as a sign of duality, a connection to the supernatural, or a mark of divine favor.
So, to wrap up this explainer, I really want you to remember that your genetics are anything but random. From the ultimate melanin shield that allowed early humans to cross sun-scorched plains, to the structural light tricks that lit up the dim Ice Age winters, every single shade of eye color is an evolutionary victory. The next time you look in the mirror, take a second to think about the incredible biological inheritance sitting right there in your iris. What ancient, unforgiving environment did your ancestors' eyes conquer to get you exactly where you are today?